6,480. Now here's how you can recognize the doctrine of the great year. You look for zodiacal imagery, because we're talking about all of this motion of the vernal equinox is taking place through the zodiac. So if it takes 25,920 years for this vernal equinox to go through one complete cycle of the zodiac, it takes 6,480 years on average in each season of the great year. And then in turn, if we divide that number by 3, it's going to give us the great month, the Platonic month. 2,160. So when we talk about a cosmic month or a month of the great year or a Platonic month, we're talking about a period of 2,160 years. If we go back 2,160 years ago, we find that the vernal equinox is shifting away from the constellation of Aries and beginning to shift into the constellation of Pisces. Of course, bear in mind that the constellations are not of uniform dimension in space. But the great wheel is divided into 12 slices that are each equal. So that wheel is turning. See, this is the planet turning on its axis. And that wheel, if you picture like Ezekiel described it, a wheel within a wheel. You have a wheel turning, and then you have the fixed stars. And those fixed stars are giving their power and character to the inner wheel. And all of the forces from the cosmos that are entering the solar system are being filtered through this turning wheel. Okay, it's almost like a great filter that determines what wavelengths of energy get through, what wavelengths of energy are going to be buffered out or damped out. So this is changing because the Earth's relationship to the cosmos is shifting through the course of this 26,000 year cycle. This is kind of my theme right here. In the book of Revelations, it says, I saw a new heaven and a new earth, for the first heaven and the first earth were passed away. What is getting at there is that through the course of this changing great year, there is, just like in the course of our annual year, there are great changes that occur, particularly if you live in the more northerly or southern latitudes. You'll notice if any of you grew up, say up farther up north, you'll know that the season changes can be pretty distinct. And of course they are here too, but the idea is that in the course of the year there can be tremendous changes. Well, as there's tremendous changes in an annual year, an annual cycle around the sun, there are also tremendous changes in the great year cycle. But when we talk about going from, in the annual year, we could talk about, the season of summer and the season of winter, separated by autumn and spring. In the great year, there is a season, there is a summer of the great year, and there is a winter of the great year. Scientific research, unbeknownst to most scientists, have confirmed the archaic tradition. And they acknowledge and admit that there was a winter of the great year and a summer of the great year. They refer to them rather as glacial ages and interglacial ages. And I'm going to show you a chart in a minute as we get into it here, that these great sweeping changes of climate have been perfectly modulated by the tempo of the precessional cycle. So let's move on. The key to understanding the doctrine of world ages is embedded in the geometry of time. What? What? This is the geologist's view of time, and we're not going to spend a lot of time looking at this. The only thing I want to call your attention to, because we are going to kind of be correlating ancient science with modern science, is we're going to look up here at the quaternary. That's where we're at now. And actually, this line up here represents the present. Okay, so that line right up there, that represents here, us tonight, sitting here. Then we have the Holocene. It goes back to 0.01. That's 10,000 years ago. And then that was preceded by the Pleistocene, which you can see is 1.6 million. So the Holocene, our present geological epoch, is just a little part compared to the Pleistocene. In fact, I even suspect that the Holocene isn't really even a separate epoch. It's just part of the Pleistocene. Well, the Pleistocene, you'll notice that what marks the transition from the Pliocene to the Pleistocene also marks the transition from the Tertiary to the Quaternary. So that was a relatively major shift there that even geologists acknowledged for many, many years, that there was quite a shift there. What was the thing that the geological scientists actually began to see that caused them to go, well, this change is dramatic enough that we're not only going to give it a new epoch, it's going to be a whole new period. Linda, what was it?
Not on the top of my head.
Okay. No. It was the beginning of the cycle of ice ages. In fact, the boundary between the Pliocene and the Pleistocene is essentially defined as when did this most recent cycle of ice ages commence? Because back in the Pliocene, it appears that there weren't this oscillation back and forth. Some other mode dominated Earth change then. Something shifted right there around 1.6 million years ago, and it caused Earth's climate to begin this oscillation. Some estimates are that there may have been 40 periods of glacial age, followed by interglacial age, followed by going back into the glacial age. Well, as we'll see here, when we begin to look closer at the scientific documentation of these climate change events, we discover that the ancients had already set down and given us very precise determination of the timing and tempo of these changes. So we're just going to proceed past there. Here's another graphic that again shows that precessional motion. And if we were to look at the Earth from out in space, we would see that the Earth's equator, again because of that 23.5 degree tilt, the Earth's equator projected into space is what we call the celestial equator. The celestial equator is tilted with respect to its orbital plane. Well, it's that tilted relationship between those two great planes, the orbital plane and the celestial equator, that creates this X marks the spot. So you have a spring equinox, and on the other side you have a fall equinox. And it's where these two planes intersect is where day and night, that's the balance point. Day and night are of equal duration. And it's this point of intersection, it's because, look at the dashed line, this is Earth's equator. As Earth's equator is moving like this line is also spinning around, and therefore this point of intersection between the orbital plane, which is fixed, and the celestial equator, which is moving, this X marks the spot, is moving through space. And it's that motion, it's 50 seconds of arc per year, and it's that motion that swings around, bringing us through this succession of ages, the age of Taurus, the age of Aries, the age of Pisces, the age of Aquarius, then going to be the age of Capricorn, etc. And if we were to look at the heavens, the night sky, during the course of this cycle, we would see right here is our North Star, and this little hatch mark next to it is where our North Pole is. And you can see that our North Pole projected into space comes very close to this star, but not quite exactly. And then you're going to see that over the course, the motion has been this way. Notice here, 24,000 AD, so 24,000 years from now, it's going to coincide where it was in 2000 BC. Here's where it was, here's where the pole was in 0 AD. Roughly 1,000 years ago it was here, now it's here. Another 1,000 years, 1,000 years, halfway through the cycle of 25,920, it's going to be up here, and you'll see that Vega will be our pole star. And there's not a lot of stars. We've got the stars Deneb will be a pole star for a while. And you can see what's called the ecliptic pole. That's the magic point around which Earth's axis is spinning. So this is the 25,920 year cycle. And it's that cycle, that wheel right there, that the ancients referred to as the Great Year. So it has an astronomical basis. Here's another depiction to try to help you visualize it.